The Robotic Systems Enterprise takes part in the AutoDrive Challenge 2. The goal of this competition is to achieve Autonomy Level 4 on the provided Chevrolet Bolt EUV, meaning that the car is autonomous for most scenarios and a driver is not required behind the wheel. Competition takes place at M City, where various scenarios are given to test the car's performance against other competitors. In order to efficiently complete all of the requirements, the Robotic Systems Enterprise divides work between 5 separate teams. The teams are Human-Machine Interface, Mapping and Planning, Perception, Safety and Testing, and Simulation and Controls. First, our Perception team. For our localization system, we first must extract visible pole-like objects from our environment and associate them with pole-like objects that we know to exist. Here, you can see images from our single LiDAR scan and the extracted poles that we got from that LiDAR scan. With our known collection of poles, we use an error minimization function to locate the vehicle in reality, effectively pulling the vehicle's model of its position to align with reality. From there, we update the rest of the systems to use the calculated position, allowing the rest of the vehicle to function correctly. Here, you can see our localization challenge. Now, onto our Human-Machine Interface, otherwise known as HMI team. Our HMI team developed a visualizer screen that displays the vehicle's planned route and detected obstacles overlaid on top of a map. The interface enables users to expand or collapse the directions panel and dynamically adjust the map's zoom level for improved usability. Our simulation team integrated the control stack from the vehicle into an Unreal and MathWorks simulation so that other teams could test their designs in a simulated environment, allowing more diverse scenarios to be tested faster. Here is a first look at one of the M-City Ross simulations. Here is another look at the M-City Ross simulation. They also worked on a development and testing architecture that allows changes to the system to be automatically built, tested, and deployed. Here, you can see the CI/CD architecture. The dashboard allows for users to see what is wrong. They can see the failed diagnostics as well as the successful diagnostics. The console output also can give more in-depth feedback on those diagnostics. And the pipeline overview shows that the stages have passed and failed. Now, our controls team. Our controls team tested diagnostic messages and worked with the software to support testing with the car. Tracking the stage the car is in for the autonomous program can monitor and streamline diagnostic messages to give the stage steps. This tells us which error kicked us out of autonomous mode. Here is the sliding mode controller. Here is our safety and testing team. Our safety and testing team tests and validates the vehicle systems to make sure the vehicle is meeting requirements. Here, this video is showing a real-life test the safety and testing team did. They were able to select an address point and the car went straight there. They also update our safety documentation, discussing the requirements for the vehicle, the acceptable criteria, and lastly, whether the vehicle passes or fails based on those requirements. Finally, our mapping and planning team. Our mapping and planning team makes sure that the car knows where it is and where it needs to go without getting into a car crash. This year, they created a new collision detection system so that the car knows when an object is blocking a path and can move around it. Here is an image showing collision detection. They also created adaptable path acceptance software so that if the car plans from a point that it can't drive on, it will try different points to hopefully create a path that the car can actually plan on. Here, the images show the before and after the adaptable path acceptance has been implemented. Here is a list of all of the sponsors that contribute to the AutoDrive 2 Challenge this year. Thank you to them, as well as our academic advisors Darrell, Robinette, and Jeremy Boss for allowing us to be able to take part in such an event. You can locate the Robotic Systems Enterprise at any of the links shown on screen. Thank you so much for listening.